Good morning everyone. In today's session we will learn about C input and output. So we will see how we can give inputs in a C program, and for those inputs how we can generate outputs. Generally input and output is divided into three types: formatted, unformatted and binary. So let's look into how it works. In C, input-output falls into three types: formatted I/O, unformatted I/O and binary I/O. Formatted I/O converts between text and native values with specifiers like %d, %f and %s. Unformatted text I/O reads and writes characters or lines directly. Binary I/O transfers raw bytes exactly as stored in memory. Formatted I/O uses printf, scanf, fprintf and fscanf for readable text output and structured input. Scanf is strict. It returns the number of successful assignments or end of file, and bad input can leave characters in the buffer. Unformatted text I/O uses getchar, putchar, fgetc, fputc and fgets and fputs. Fgets is often safer because it limits input to the buffer and preserves the new line if space allows. Binary I/O uses fread and fwrite for arrays, records and performance sensitive storage. It is fast and exact, but files are not human readable and may not be portable across systems. So let's summarize the whole thing in a single tabular form, naming it as style, function, best for, strength and limit. So formatted style functions are printf, scanf, which are best for readable text. Its strength is precise formatting and its limit is strict parsing. Next is the unformatted style. Functions are fgets, fputs, best for line-based text. Strength is safer buffering and limit is less structure. The last one, style binary. Functions are fread, fwrite, best for raw data. Strength is fast and compact. Limit is portability issues. Use formatted I/O for structured text, unformatted text I/O for direct control and binary I/O when exact bytes matter. Next, formatted I/O structure and control. So let's look deep into how formatted I/O works. Formatted I/O in C converts between internal values and human readable text using format specifiers. It is the standard way to control how data is printed and parsed. Printf and scanf handle formatted input and output on standard streams. fprintf and fscanf do the same for files. Printf returns the number of characters printed, while scanf returns the number of items matched and assigned or end of file on early failure. So the common format specifiers are %d, which is used for signed integer. Example, printf int %d within the quotes. Next one, %u, used for unsigned integer. Same, printf u int %u. %c, single character. printf, char, %f used for strings. Example, printf str %s, %f floating point. Example, printf float %f, and %x for hexadecimals, printf hex %x. So these are some of the common format specifiers which are used in formatted I/O to give input in our programs. Width and precision can fine-tune layout such as %s -12s, %8.2f for aligned text and fixed decimal output. So in this structure we can see we can give integer values, unsigned integer values, character values, strings, floating points which is decimals, and hexadecimals. Next is the binary I/O, which is for raw bytes and structures. Binary I/O transfers data exactly as it exists in memory using functions like fread and fwrite. It is useful for arrays, structures, and performance sensitive storage because it is fast, compact, and preserves bytes exactly. Advantages: fast, no text conversion overhead. Compact, stores native binary data. Exact, preserves bits byte for byte. Disadvantages: not human readable, may not be portable across systems. Binary I/O is common for image files, custom archives, and other formats where speed matters more than readability. So, binary I/O is used whenever we are entering any arrays, structures, or maybe some image files. So, binary I/O does not have the human readable form. It is rather stored in the bits by bits. The foundation, streams, and standard I/O. C treats input and output as streams, ordered flows of bytes or characters between your program and a file, terminal, pipe, or device. Most core I/O lives in stdio.h header file, including printf, scanf, fgets, fopen, and fclose. C uses three standard streams: stdin for input, stdout for normal output, and stderr for errors. Keeping them separate supports direction and cleaner error handling. stdin standard input, usually the keyboard or a redirected file. stdout standard output, usually the terminal or a redirected file. stderr carries errors and warnings and is typically unbuffered, so messages appear immediately. Why streams matter? Streams let the same I/O code work with terminals, files, and pipes. Flush stdout forces buffered output to appear. Text versus binary I/O. Formatted or text I/O uses format strings like %d and %f. Unformatted binary I/O works with raw characters or bytes using functions like fread and fwrite. In short, use standard in, standard out, and standard error deliberately. Use formatted I/O for readable text and binary I/O for exact byte preservation. Next is the unformatted I/O or raw data transfer. Unformatted I/O reads or writes data one character or one byte at a time. With no parsing or type conversion, use it when you need exact control over the stream, such as echoing input, preserving white space, or building simple text filters. Unlike formatted I/O, it does not interpret numbers or delimiters. You decide when to stop, how to detect end of file, and how to handle validation. Getchar reads one character from standard input and returns as int or end of file on end of file error. Putchar writes one character to standard output and returns it on success or end of file on failure. Best used when you need direct, predictable transfer with no formatting overhead. Related concepts: end of file marks the end of input, and buffering can delay visible output. These functions are defined in stdio.h header file. Other useful functions are fgetc or fputc for any file, ungetc to push characters back, and fread or fwrite for raw bytecodes. The following is a simple example to print a character. Int c, while c equal to getchar not equal to end of file if c greater than a and c less than z, c equal to c minus a, putchar c. So let's see what are the different approaches and how does it work for other functions like getchar and putchar. Getchar returns one character from stdin or end of file. When to use it: character loops, key handling, and text filters. Next one is the putchar. What it does: sends one character to std out or end of file on failure. When to use it: streaming output, echo programs. Next approach is the scanf or printf. Pass typed input and format typed output, human readable input or output. Next is character by character, a practical example. Unformatted I/O in C works at the lowest level, one character or one byte at a time. Use it when you need exact control over input and output, such as echo programs, line counters, and simple text filters. Unlike scanf and printf, it does not parse numbers or split fields. Functions like getchar return the next byte from stdin as an int, and putchar writes one character to std out. This makes them ideal when every character must be preserved exactly. How it works: a typical loop reads one character at a time, echoes it, and stops at new line or end of file. That pattern is common in terminal filters and simple stream processors. Use this approach when you want raw input exactly as typed, including white spaces and punctuations. So some of the useful functions: getchar reads from stdin and returns is end of file or error. Putchar writes one character to std out. Getc or putc work with any stream, and fgetc, fputc are the file stream versions. Now the example code is written over here to see how the character is printed. Ch must be int, not a char, so it can hold both character values and end of file. So a quick comparison between all the functions. First one, getChar. Its stream is standard in or std in, used to read one character. Notes returns int or end of file. Next function is the putChar. The stream is std out or standard out. Use write one character. Notes good for echo output. Third one, getC. Stream is any input stream. Use read from files or pipes. Notes more general than getChar. And the last one, putC. Stream is any output stream. Use to write files or pipes. Notes more general than putChar. In practice, use getChar and putChar for keyboard to screen programs and the stream specific versions when you need files or pipes. Next, character I/O functions, reference and comparison. C's character I/O functions all work 1 byte at a time. Use getChar and putChar for standard input and output and use the stream based versions when you need to work with files or other file streams. So the comparison is divided into functions, stream, purpose, return value and a key note. First function is the getChar. Stream, as we know, is std in or standard in. Purpose, read from standard input. Return value, it gives an int. And key note, good for simple keyboard or redirected input. Next one, putChar. PutChar, as we know, is std out or standard output. Write to standard output and returns int value or end of file. Keynote, good for simple screen or redirected output. Third function, getC. Stream is any file. Purpose, to read from any input stream. Return value is int or end of file. Keynote, general purpose input, usually a macro. Fourth one, putC. Any file, write to any output stream. Return value is int or end of file. Keynote, general purpose output, usually a macro. Next one, fgetC. Any file, stream, purpose, read from any input stream. Return value int, function version of getC. Next, fputC. Stream is any file. Purpose, to write any output. Return value is int and keynote is function version of putC. Rule of thumb, use the micro style getC or putC for convenience and speed, and fgetC or fputC when you want safer evaluation of the stream argument. Always store the result in an int so you can distinguish a valid character from end of file.